Hey, folks. In this unit, we begin with Chapter 7. And in Chapter 7, we cover long-term memory encoding and retrieval. In other words, what we're going to be covering is why you forget things, why we all forget things, and how we can best make sure that we remember things. So lots of good stuff in here. This is sort of my favorite part of this class. I have sort of lots of favorite parts of this class, but this is where a lot of my research interests are. It's just in trying to understand how we can best remember the information that we're trying so desperately to hold on to. So let's get going. I like to start out here with a thought question to get us thinking about why we forget things. So let's imagine Martha thinks of 11 items to get from the grocery store, but she doesn't write down a list. She's at home. She's leaving the house. She can remember all 11 items. Okay, so she's got them. She's got all of them down. She doesn't have to write any of them. She could tell you all 11 right now. She leaves the house. She goes to the grocery store. By the time she gets there, she only remembered 8 of them. So she ends up coming home with 8 things and just can't remember what the other things were. Doesn't even remember that she forgot them, maybe, right? And just comes on home, and it turns out that she's missing 3 of the things that she needs. So what causes her to remember fewer items when she gets to the store? Now, oftentimes, I ask this question, we think about it, and it's like, oh, well, she just forgot. Well, that's not really an explanation, right? What went wrong? What caused her to forget? And one thing that I want to push on is you may be thinking of one answer here based on what you know about cognition or memory, but I want to push on here is that there are actually many answers that are possible for this. There are probably many reasons why Martha forgot those 3 items. None of those reasons are probably that she has some memory disorder, right? It's normal to forget things. So what about normal memory processes and normal forgetting could account for this? Well, one way to think about the possible reasons why Martha forgot 3 items is to break down the stages of memory. So we've got 3 stages going on, and the first is what we call encoding. And this is a computer science term. If you remember, a lot of cognitive psychology got started around the same time as computer science, and we borrow a lot of ideas from computer science to think about how the human mind works. So encoding is like, coding in computer science. So we get the information in to our memories. Okay, so encoding into long-term memory is when you take information from the outside world, you acquire it, and then you transfer that information into your long-term memory. As we talked about already, this requires your attention and your perception. So Martha had to attend to the information that she's trying to remember, right? And she needed to so she probably just thought of those on her own, things that she needed. She might have perceived something. She might have looked around her kitchen, maybe, and saw that the milk was almost empty, maybe, right? And then thought about that. And so that's how she got her list, right? One thing about encoding that we'll learn in this video is that it can be done sort of at different levels. And so a big question is, how well did Martha encode the list? So she encoded it well enough to remember it while she walked out the door, but maybe she didn't encode it well enough to hold on to for a long period of time. So we'll talk about different ways that you can encode information that are more or less durable. The next stage is storage. So you've encoded the information, you've got it into long-term memory, and now you're storing it. And sometimes things can go wrong because essentially the information never got it into long-term memory in the first place. Maybe it was in your working memory and we never actually encoded it. And so we had it stored in working memory, but not in long-term memory. In Martha's case, this probably isn't an issue. Martha could remember those 11 items before she left home. So in all likelihood, she had that information in long-term memory, or at least a lot of that information in long-term memory. The last stage is retrieval. So Martha got the information into her memory. She stored it into the long-term memory, at least for some amount of time. But now she gets to the store and she needs to retrieve that information back out. When she thinks about the list, or when she goes around and recognizes whether she needs something from aisle 2. Okay. This is transferring that information back from your long-term memory back into working memory so she can think about it and pick up the things that she needs. And what's interesting about retrieval, which we'll cover in the next video, is that it very much depends on context, situation, and cues. Okay, so the big thing to think about here is, well, how are things different when she remembered the list at home versus when she remembered the list at the store? Well, of course, the world looks different in your kitchen versus at the store, right? In your kitchen, you have access to your refrigerator and your pantries, right? So you have some cues as to what is missing, right? You have the context in which you came up with the list in the first place was in your kitchen, right? And so when you thought of that list, you might have been looking at different things in your kitchen. And now when you're at the store, those things aren't around anymore, right? And when you're at the store, rather than just a list of 11 items, you now have hundreds and hundreds of items, right? And so maybe the appearance of this whole aisle of cereal is perhaps distracting us from being able to retrieve the fact that we need onions. So something could have gone wrong at each of these stages, likely having to do with either how well she encoded the information or the difference in the situation from when she encoded it versus when she tried to retrieve it at the store. But what do I mean by the quality of encoding? Well, we'll talk about a number of different effects here that can affect how well encoded information is. We'll talk about levels of processing, elaboration, generation, spacing, imagery, organization, and retrieval practice. And all of these factors can affect the quality of your memory. And just as a preview, all of these factors seem to work in a generalizable way. So these factors are useful for people. They're useful because they take advantage of how our memory works and how our memory stores information. And that seems to be true across people. So there aren't some people who benefit from generation effects and some people who benefit from imagery. It seems to be fairly generalizable that these are useful. Okay. So our first sort of delve into this encoding quality idea comes from levels of processing theory, and you'll actually do a COG lab demonstration on levels of processing, so you can see what this is like. But the general idea is that your memory, the quality of your memory, will depend on how the information is encoded. So not how long you spend studying it, though of course that's useful, but how deeply you study that information. Okay. So in the levels of processing research, they'll manipulate the depth of processing. Okay, so they'll have shallow processing tasks that pay little attention to the meaning of words, for example, and focus more on physical features, like is it capitalized or lowercase? Does it rhyme with the word goat, right? So rhyming, what it looks like, just repeating a word over and over again and just hearing it in your phonological loop, that's shallow processing of information. Okay, highlighting information and seeing it in yellow versus black, that yellow color is pretty shallow processing of the information. Okay. Deep processing is when you pay close attention to the meaning of what it is that you're studying or trying to remember. Okay, and then the levels of processing task, this might have you put the word in a sentence, right? Or think about a synonym for that word. So you're thinking more deeply about what it means rather than what it looks like or sounds like. So this is a pretty basic manipulation, right? And then levels of processing theory works, has a ton of support for it. Your cog lab will show that deeper processing leads to better memory. And in general, the lesson is when you're studying something or when you're trying to remember something, trying to remember somebody's name or trying to remember a grocery list, don't just repeat it in your phonological loop. Think about what it means. Okay, so instead of, bread, cheese, butter, ham, think, oh, I need stuff for grilled cheese. So levels of processing theory came out and has a lot of support associated with it, but there are some sort of theoretical issues with thinking about levels of processing. And the main issue is that if I just tell you to think of something deeply, it's actually hard to independently define what I mean by that. So let's consider two tasks. And I want to make a theoretical prediction about which one is going to be deeper. Okay, so I'm going to give you one of these two tasks. And I want to say, oh, well, according to levels of processing theory, the one that is deeper processing will lead to better memory, right? Okay, so which is deeper? Thinking of an example from your own life or coming up with a new example? So let's say you're studying multitasking. Is it better to think of an example of multitasking from your own life, or is it better to come up with a new example, not from your life, but about some imaginary person? Okay, which one of those is deeper? I actually have no idea. I could run a test and I could see which one performed better and then assume that that was deeper. But did you perform better because it was deeper, or was it deeper because you performed better? We're in sort of a loop. Okay, so when we get to these more subtle manipulations of encoding tasks, it sometimes becomes hard to justify what we mean by depth. So many researchers find it more useful to think of depth of processing based on elaborative rehearsal. So how much elaboration did you do on the information? And in both of these cases, you're doing a lot of elaboration of the information, coming up with an example in both cases. And so I wouldn't really expect any difference. Okay, so this general idea of elaborative rehearsal goes beyond what we've already learned in terms of rehearsal, right? So we've talked about how you're going to lose information from your working memory unless you rehearse it, right? We can hold on to it for about 18 seconds, but we can hold on to it longer if we rehearse. Okay, that's nice for maintaining information. So that's sort of maintenance rehearsal, just kind of repeating stimuli in your head to keep it active. Table, goat, bucket, purple, monkey, dishwasher, right? Just repeating it, or repeating your shopping list, right? Milk, bread, eggs, butter, cheese. Right? We do this all the time, just kind of trying to keep things active so that we don't lose it before we need it later. But if you really want to get that information stored long term rather than having to just maintain it, you want to elaborate on that information. So you use the meaning to help transfer and connect information to long-term memory. So for example, if I need onions, bell peppers, and celery, I can just chunk all that together into this idea I already have in my brain, right, of the Cajun Holy Trinity, right? So I need to get the Cajun Holy Trinity. That's easily going to get me those three items, and I have stored that in my memory because I've also associated with it with the fact that I'm making gumbo. In general, the rest of the techniques that we talk about here are going to try to enhance your memory by encouraging this elaborative rehearsal. So rather than just maintaining information passively, repeating it, it's going to require, these techniques are going to encourage or require more elaboration on the material based on what it means. There's a couple of ways to encourage elaborative rehearsal. One is to encourage people to pay more attention to the information and to give more effort. So rather than just passively thinking about the information, think about it more effortfully, and we'll cover some effects there. Levels of processing we've already talked about. The generation effect and spacing effect work there. Another way to elaboratively rehearse information is to make connections between what you're trying to learn and other ideas. We'll talk about a few effects there: self-reference, imagery, and organization. Finally, a good way to elaboratively rehearse the information is to practice retrieving that information. Because having to pull it out from memory on your own tends to enhance your memory. So we'll talk about that kind of by itself. The reason we talk about by that itself is because it's both more effortful and creates some connections. So this will kind of come up a couple times. So the first effect to talk about is something called the generation effect. Okay. And the basic finding here from the 70s is that if you generate a response, you get better memory compared to reading it. Okay, so it might seem like, if a teacher provides you all of the information, that's going to be better than making you generate it yourself. Because, well, if you generate it yourself, you might make a mistake, right? Well, it turns out you generating the information yourself, as long as you're able to do so, leads to better memory of that information because you actively attended to that information, put in effort to create it rather than passively receiving it. Okay? So the way we demonstrate the generation effect, which has been replicated hundreds of times, it works every time for basically all people. Okay, is you have a reading condition where you just get these word pairs like king, crown, and you read those words. Maybe even you read them out loud to make sure that you're processing them, right? And then you have a generation condition where you get the word king and then the letter CR. And you never see the word crown, you just get CR. But I can make an association on my own between the word king and the word crown, and I can generate the rest of this word pair and say, oh, this is king crown. Requiring me to generate that word crown as opposed to just reading it out instead of in, right, allows me to do better on the final test. So on the final test, you get the word king and you have to fill in the blank. Okay. And, sometimes you get the word king and you might write, say, queen, right? Or prince, right? Or kingdom, right? But in this case, the correct answer is crown because that's the one you learned paired with it. And it turns out that if you had to generate crown on your own, as opposed to just reading it, you do a lot better on that test. And this is a pretty strong advantage for the generation condition. Okay, so the lesson from this is don't just read the information provided to you, make sure that you're generating it. Make sure you're doing something with it. Okay, so if you're going through flashcards, right, don't just flip from one side to the other and read them, right? Look at one side, try to come up with the answer on the other side, then flip it over and check. Okay. In fact, make those flashcards yourself instead of pulling them down from MindTap, for example. The next effect to talk about, which you've probably heard of before, is something called the spacing effect. And the spacing effect sort of is oftentimes put up against a study strategy called cramming, which a lot of you do. And I know that a lot of you cram because I can see when you access materials on MindTap and when you access materials before the quizzes and when you complete the quizzes, right? So a lot of you are cramming for those quizzes. It's a very common study strategy. Research shows it to be ineffective. Okay. It feels nice to cram before an exam sometimes because I just studied all this information, so the information on the exam is really new and fresh. Right? But if I actually want to learn that information for the long term, not just for the quiz right now, if I want to actually remember that information, maybe for a final exam, it's actually a lot better for me to spread out the studying of that information over a few shorter study periods. So as a demonstration of this, what the studies look like First, it's really important that you make sure that all the participants study for the same amount of content and that they study the same content for the same amount of time. Okay, so when we say spacing, I don't just mean study more. I don't. So when your professors say, spread out your studying and do some on Tuesday, some on Thursday, some on Saturday if you can, right? They're not saying study 3 times as much. They're saying take the amount of time that you spend on that content and divide it up into 3 pieces. So in the spacing effects research, they'll have people, let's say, study for an hour, right? And they'll spend that whole hour studying the content of a textbook, restudying the content of a textbook, going through it over and over and over again, right? Until they're ready. For spaced practice, you might spend a half an hour studying, take a break, and then half an hour the next day. Okay, just that split of that hour of studying into 2 days of half-hour studying, and you could study for some other class at the same time, right, gets us a pretty strong advantage. So there's a distinct advantage for that space practice over mass practice. And people say, well, why is this? And they might even say, well, that doesn't work for me. When I go back to study something the next day, it's harder, right? So the second time around, if I'm doing it right away, it's really easy, and the next day, it's hard. And in fact, that's exactly why it's better. Making that second study period, making that second half an hour harder on yourself as opposed to easier on yourself, makes that information, because the information is less familiar to you, it's a day later, you work harder to understand it. So as opposed to just the information getting easier and easier and easier over the course of an hour and feeling really good and familiar, we work for a half an hour, then the next day have to work harder because we've forgotten some of it. And so you're putting in more effort twice as opposed to less effort once. Does that make sense? If anybody is an athlete, you might understand how this works, right? It's better to spread out your workouts so that you're doing them across multiple days as opposed to just doing all of your working out on just Sunday, right? So I could spend 5 hours working out on Sunday, or I could spend 1 hour a day for 5 days. And anybody who's an athlete will say you're always recommended to do a bit less over the course of 5 days, because over the course of that 5-hour period on Sunday, you're not going to get as much out of it. Okay, so that's the spacing effect. Last effect to talk about in this sort of effort area is the testing effect, or retrieval practice. And it turns out that testing your own memory takes more work than restudying information. Certainly takes more work than going back and highlighting information. And because it takes more work, it leads to superior long-term memory. Those tests require retrieval practice. You're practicing retrieving the information from memory as opposed to just passively pulling it in. It's pretty similar to the generation effect, except in this case, we're not generating it new, we're retrieving it based on what we already read. So essentially in these studies, they'll have people read information and then they'll either reread it, like go back and read that chapter again, or read this summary of it, or they'll test people on the information. And it turns out that right away, going back through the text is a little bit helpful, right? And the reason is that we don't do perfectly on that practice test, and so going back through the text gets me a little bit more information. But if I put any delay on this at all, 2 days, a week later, the testing condition is much better than the rereading condition. And this has been replicated dozens and dozens of times. Okay, so that practice test condition outperforms restudy at a delay. This is why you take practice quizzes. This is why you do things like mastery training, right? Because they require you to practice taking a test, which should help you down the road. One way to kind of tie these together, okay, is by a term that's been used called desirable difficulties. When you're trying to encode information, certain ways of making the information more difficult to process can be desirable because you put more effort into processing that information, and you therefore will encode the information more deeply in the long term. So we can think about these across these different examples. So in levels of processing, the deep processing condition where you think about what it means versus what it looks like is more difficult. So it's more difficult to put a word in a sentence than it is to decide whether it's capitalized or not, right? Even though it's difficult, it's better for your long-term learning. Generating the word crown as opposed to just seeing the word crown is more difficult, but better for your long-term memory. Spaced practice makes that second practice session more difficult, but better. And testing or retrieval practice is more difficult than going back through the information, but it is better. And what's hard about this, what's kind of counterintuitive about this, is that when we're students or we're learning something new just in our everyday lives, we interpret these tasks sometimes as being ineffective. So generation, spacing, doing a practice test, doing flashcards, and really testing myself on the backside of the flashcard, right? Thinking deeply about what something means as opposed to just reading through it. All of that might make it seem like, well, this just isn't working for me. Or I don't like studying that way. Or I feel like I get it faster the other way. So it's just faster for me to go through and highlight. Yes, it is. And it's easier, right? That's why it's worse. Okay. And the fact that each of these processes are more difficult and make you work harder at the information is actually evidence that you're encoding the information more deeply. Okay. This is like adding weight to that weight training, right? If I'm just constantly working with very low weight that's very easy for me, I may feel like I'm accomplishing something, but I'm not necessarily doing so, right? I can get more bang for my buck. I can actually get more efficiency out of the time that I do study, because we don't have unlimited time, right? I can get more efficiency out of that time if I work harder for that half an hour, as opposed to working easier for the same amount of time. Okay, we're going to leave it there for this video. In the next video, we'll talk about not just working harder, but making connections between ideas to really boost your memory for the content.